Okay. Paul? I don't know. So it's 3:50, so we're going to start pretty soon. We've got a very full agenda. And I'm making loud starting noises so the people in the hall can hear that and think about coming in. I know.
Do we
closing the door? That's a good move, actually. That'll make them nervous.
Thank you. We're looking for a minute taker. Minute taker.
Paul Hoffman, you're an upstanding citizen in the IETF. Then you'll write very clear minutes because you'll force us to clarify ourselves.
Thank you, Paul.
Thank you,
are
Paul.
a friend. And
you're a gentleman.
All right, welcome to session 1 of HTTPBIS of 2 sessions we've got this week. This is the Note Well. It is Tuesday afternoon. You have probably noted well by now. These are the terms that govern your participation IPR-wise in the IETF. If you do not understand them, your chairs and your ADs are more than happy to have a conversation to help you understand them. So we have a scribe. Thank you. I've got 2 sets of blue sheets that Mark will distribute around the room. And we will open the agenda for bashing. My understanding is someone would like to reorder 2 of the presentations, and if that's probably something we can accommodate, but this is the agenda for today. We're going to start by going through each of our active drafts that the working group has adopted that isn't at least off to the ISG. And then we'll talk about some proposed work, and we have a couple informational presentations after that regarding how push, which was part of the HTTP2-7540 standardization, is playing in the real world. Would anyone like to make any changes to the agenda?
Yeah, Chris would. Would it be all right if we swapped the Helium and SNIL service drafts? That the second one happens to conflict with the start of CFRG, which is rather unfortunate, and I would like to attend both. So it's okay with the presenters and everyone here. Is that okay?
Yep. So I double checked this with the authors and the presenters, and they're all cool with that for both drafts. But does anyone else have an objection? See no objection. That's what we'll do.
Okay. Thank you.
I was wondering if we could move also CDN loop to, I'm also conflicted with CFRG. So put Helium as the third for the proposed work, if that's all right.
Are there any objections to that? That's also fine by me. I think we're all here.
So I think the constraints we're working with here is that we don't have ECHA until 3 o'clock. We have a bunch of people who want
5 o'clock, I think.
Whatever, 5 o'clock, whatever. And then we have people who are disappearing shortly thereafter. Is this a double session? Is that what's going on?
I don't know the answer to that.
I think there might be another session somewhere else that's being split in 2.
Okay. There's some overlap. So let's just let's do alt services and then Helium, then CDN loop as the plan of record for now. But it's possible we'll be able to move through some of the active extensions like quite quickly. Some of them have very short reports to go on. So I suggest we get started on that and see how we're doing.
Right.
All right.
Sound good?
Okay.
Been doing this for a long time. I don't think we've ever had such an extensive agenda.
I know. The first time someone bashed an agenda, I was very excited, and now I kind of live in fear.
Now you understand why we.
Yeah. All right. So we're going to start with variants. Get your slides up here for you.
Okay, so the first draft is HTTP representation variants. Draft IETF HTTP is variants. We adopted this, was it 2 meetings ago?
I believe so, yeah.
Yeah, something like that. And it's been coming along pretty well. Next slide. I think it feels like it's getting close to done, or at least ready for some sort of feedback / implementation loop. And I think that's the big question in front of this draft is, I've been talking to folks, we have some implementer interest, we don't have any actual implementation yet, and so the question at hand is, do we want to go ahead and publish this? Once we resolve our issues and we go through our review process, which is we're not quite there yet, but we can see there from here. Do we want to try and wait for implementations, or do we want to just go ahead and publish it? Maybe it's experimental or something else and see how it goes. Not yet. So since I wrote these slides, I've been talking to some folks. First of all, I'll ask the question is, does anyone in the room intend to implement this in the near future? Okay, so I have a hand up. I knew about that hand. That's why I asked the question. You never ask a question you don't know the answer to. So I think what we're going to do is we're going to work through the remaining issues. Leif has said that he thinks this is something he can implement as a plugin in Traffic Server with Brian's help, perhaps, and over a very reasonable amount of time. I'm not going to talk about the time scale that you gave because I don't want to make a commitment for you, but a reasonable time scale. And then we'll based on that feedback, and maybe if other folks get interested, then we'll take a look at where we're at after that, if that makes sense. Okay, great. And that's of course in the cache side and cache implementation. The other half of implementation here is generating the headers so that the cache can take advantage of them. I'm not as worried about that because that is if you've implemented vary generation based on a file system, for example, this is a very small step from that. It's not a big deal in something like Apache. Next slide. So I think there's just one issue that I wanted to talk about today, which is the more expressive variant key issue, whereby we had some discussion that right now the formulation of the variants header. Yeah, the formulation of the variant key header is such that you list the available options for each component. So for example, if there's a DPR and you can have a possible value of 1 or 2, then variant key says, well, this particular representation has 1. And there's another, and then it has another way that says, I can also express this key for that. We've been having a discussion about expressing the variant key in a different format. So it's basically a set of alternative variant keys for this representation that for the response that the variant key header occurs in. And that I think the feedback we got on the list just actually yesterday from Yoav was that he really liked that because it's more expressive. It allows you to avoid situations where, if there's a matrix of 4 different options that the variance builds and 3 of them can be satisfied by 1 response, this gives you the ability to say, okay, well, this response can be used to fill those 3 holes. And that isn't currently possible in the current spec. So we talked about that. I feel better about that. The only issue that came up, I think, is that gave Leif a little bit of heartburn, and from an implementation complexity standpoint. But we talked through that the other day, and I think that we can address that by writing the spec such that only the first variant key in the variant key header, because it's a list, has to identify the representation that it occurs within. And that way, if he wants to, he can just chop that off and use that, lose some cache efficiency, but he doesn't have to fill all the other holes in that matrix in his cache by creating dummy entries or whatever you want to do. And from his standpoint, that's a much easier thing to implement, but it gives him a path to later on address support those other values so that you get better cache efficiency. Is that about right, Leif? Okay. And so I think this doesn't need much discussion. I just wanted to check to make sure that nobody else had heartburn with that. Sorry?
What does it look like?
It looks like what you see here on the bottom, variant key. So that says basically, this would, if we adopt this, that variant key semantics would be this particular representation that these 2 headers occur in, identify the response with the values 2, 300, and off for DPR, viewport, and save data, respectively. But this response can also be used for the 1, 600 off and 2, 600 on responses. And the use case driving this was, Yoav talks about this a lot. When you have interdependent headers, for things like especially, DPR, viewport, and save data are good examples. Often you'll have different combinations of those that could be satisfied by the same low quality image, for example, or high quality image. You don't want to have all those duplicates in your cache. You want to have a way to express, hey, you've got 1 entry in cache that can be used for all these different combinations of these headers. Is there another slide?
You're out of slides. So I will go
I'm
back
out of
to your
slides.
first slide for publish now or wait for experience, and note that this is a standard strat document, right? And 1 cache has provided, a lot of cooperation, right? But hasn't implemented yet.
I think I can give you another cache in the not horribly distant future.
Excellent. I was going to point out I've made some new friends from Comcast this week running one of these caches who's implementing. I'm wondering if they would be willing to suggest a intent to experiment with how this works if that implementation were made and provide some feedback?
Yes, there is intent to experiment. Not a lot of experience yet, though.
Sure. Doesn't exist.
That's all we're asking for now. That would be great. Thanks.
So my suggestion would we would essentially park this, waiting for some implementation experiment.
Yeah, that's I'm happy to leave it open for almost an indefinite amount of time as long as we actually have people doing things with it. If we don't have people doing things with it, we might as well just dispose of it in some other fashion. So
Great.
Okay, thank you.
Thanks. So you're still up there, Mark, because we're going to talk about BCP 56-BIS next.
Hi.
You don't have slides, so I'll
I
find a
don't have
nice little
slides.
interstitial here for us.
Yeah, that'd be good. So we've been working on BCP 56-BIS for a while now, and we've gone through several cycles of editorial editions and reviews. I feel like we've gotten fairly broad review of it, both from folks in the working group as well as folks outside. I regularly, including yesterday, get emails from people in the IETF that I've never met before, as far as I'm aware, but that are giving me very nice feedback on it, saying that we like this, this is very helpful, have you thought about this, or can you change this to make it more clear, or what do you think about this? And so I feel like it's a lot of eyeballs have seen it, and the rate of change on the document has been slowing down. So I'm gaining confidence personally that it's getting to a stage where it's ready-ish to ship. I think the big open question on it right now is I have an editorial issue open on it to wait for HTTP core so we can reference those nice new, very well-structured core documents in this rather than referencing the 723X series. We'll talk about core tomorrow, but I think the feeling is still that we're going to finish core around the end of the year. So I'm personally, as editor, happy to leave it open for a while and maybe incorporate some more feedback as it dribbles in and get even wider review for this document, which is always a good thing. But I'd be curious to hear what other people think about whether there's an urgency in shipping this document or not.
So Martin Thompson, I think having it is more important than publishing it at this point. And it would be really nice if this went out alongside those core specs, because I think that really sends a message that this is part of the core. And in a way, the way you use the protocol is almost as important as the definition of the protocol itself, I think. And so my preference would be to sort of try to hold it until then, as long as that process doesn't prolong itself. And there are signs that there's lots of changes coming in the core thing, but they're all really minor things, and I think we could probably say that the core thing is going to be done soon.
I hope so.
At least not 3 years away. If it were a year, I think I'd be comfortable with a year. I think any longer than that, and I think we should start to.
That feels about right to me too. Yeah, thanks. Who in the room has read the document, BCP 56-BIS? Okay, smattering of hands. Please read it.
Yeah, so this is intended as a BCP, right? So we want wide review in the room. But as positive data points, there have been about 60 issues opened against it on GitHub, almost all of which have been resolved, from a pretty wide range of parties, including people that don't participate regularly in this group. So it's getting that kind of review. You recently added a privacy consideration section. I want to make sure people look at that. My experience with talking to people working in other groups, and there was recently interest in this from the SAW group, and the DOE group was also very interested in this, right? Is it would be nice to have something not just to guide their definitions of their protocols, but to actually to be able to normatively reference to say, the security implications or the privacy implications of the HTTP portions of my spec are reflected in BCP 56-BIS, right? So if folks, want to read it with an eye towards does it answer that question, I would be interested in that. Yeah. Martin.
I'm relaying for Julian here. He says we have a few core issues where we still discuss whether it should go into core or BCP 56-BIS. And I think that's good. And then he says, so he agrees with me on that point. So that's fine.
Paul Hoffman, so the SAG message that you saw, you may have misread. Basically, he was told put BCP 56 stuff into a document that is blatantly breaking BCP 56. And it says so, it says, screw how they did it. We just wanted to shove our data over HTTP. Oh, but there's this document over there that tells us not to do it. So,
So that's an argument for the completeness and the urgency of publishing, perhaps.
well, at least now, I mean, and that document will go forwards. It's been waiting for almost a decade, but basically it's specifying something that predates, possibly even predates BCP 56, and it's a fuller specification of it. And it's someone who could care less. He's over in your continent area, so you could chat with him at some
My
point.
continent area?
Yes. Well,
Don't you know all
Oh,
this?
because we all know each other.
Yes, right. So anyways, but just to be clear, that document is referencing BCP 56 saying, yeah, screw that.
So, speaking to the privacy considerations part, and that general question, I think that writing that kind of text to have it to be able to reference somewhere is a great idea, and we should be doing that. Personally, my initial feeling is that probably belongs in core. The idea behind BCP 56-BIS is it's a guide for people who are writing new specifications or applications using HTTP, and it's also a guide for people reviewing them, especially area directors. So, you know, when that specification gets to the IESG, they can compare and make their own decision. I don't think there's currently anything in there that's something I could see an application referencing, unless it's, oh, we did do this and we're pointing to it informationally, maybe, you know, or we didn't do this and we're pointing to it informationally, but it's not really a referenceable document in that sense. Just like the original BCP 56-BIS, I don't know anybody really referencing that one either. But I'm not stuck on that. I mean, if we want to change the nature of the document, that's fine. To me, it feels like it kind of goes in core, because you're going to be referencing HTTP anyway, if you're using it.
Are there any other thoughts? Okay.
Okay, thanks.
Thanks, Mark. Secondary certificates is next. Martin, Mike, or Nick, who's going to do the honors here? We have a clicker, Mike. I don't know if it works, but you know.
Okay. All right, so as far as the secondary search draft, I'm going to go with no, it does not work.
There you go.
All right, so there's actually been a fairly broad set of changes since London. So if you go up to the next one. For the first part, in draft 00, we were sending the frames that were related to the certificate and to the requests on the control stream. But the things that we're describing for this particular stream, I need this search, and now I can proceed because this request has been answered. Those were happening on stream. There's a slight problem with that flow, though, that is not fatal in HTTP2, but will be fatal when we take the same thing to HTTP over QUIC, which is that the request with the headers likely closed that stream in that direction. So requiring that you then later send a frame on the closed stream, not so nice. So in draft 1, everything has been moved to control stream. It says, it includes the stream number of what it's referencing, but unfortunate that we have to mention it, but it makes the stream usage cleaner. So next slide. We're also being more explicit about where certificates are used. Originally, there was a flag on a certificate that was marked as automatic use, so that the client could say, I'm fine with you using this certificate for all future requests that I make. And servers have to set automatic use because clients are deciding whether to send requests in the first place. Now, there's an issue in that the server doesn't actually care whether the certificate's available, but the client might. The client doesn't know when the certificate was used or not. And so we've turned this around so that there's the ability to send an unsolicited use certificate. And if you want to apply to your certificate to every request, that's one more couple byte frame that you can send along with every request. But if you have multiple certificates, you can pick which certificate to associate with each request. And now also it's not confusing if the server turns around and asks you for a different certificate after it's seen your unsolicited one. Next slide. Also, in the camp of trying to be more explicit, instead of having clients pick an unused stream and say, I can't use this stream until you send me the certificate that I want, which is kind of hokey, I have to admit. Instead, we just say, certificate needed on stream 0. This connection requires that you provide me the certificate, which is a little bit cleaner. I would still like a cleaner still way to do this, but this is the best we've got right now. Next slide. Most of the big changes in the doc, though, have been through integration with the exported authenticators draft in the TLS working group. So the original version of the draft that we adopted and that we still had, I think, back in London, was that everything was being done at the HTTP layer. The certificate frame carried actual certificates. Then you had a certificate proof that contained a signature of something, of an exporter by that certificate. The certificate request had OID filters, and having all of this at the HTTP layer was kind of ugly. So moving to draft 1, there's no more certificate proof frame. Certificate carries an exported authenticator. Let TLS deal with all of that. Certificate request carries an exported authenticator request. All of that's encapsulated at the TLS layer. Yay, keep HTTP out of it, please. Draft 2, we got to take advantage of a new feature in exported authenticators that was added during their first working group last call, which is an exported, well, basically an authenticated refusal. The ability to send, I do not wish to provide you the certificate you've asked for. Previously, use certificate just didn't include a certificate ID. Now you actually send along cryptographically signed, I am refusing to send you what you've requested. So we're shifting more stuff into the TLS layer, doing less at the HTTP layer, and this is goodness for separation of concerns. Last major change that we've had so far is a way to detect man in the middle sooner, because if you do have a TLS man in the middle on your connection, unfortunately they do still exist. Under the old model, you wouldn't discover that until you'd done all the work of generating an exported authenticator and then it didn't validate. Now we actually stick an exporter in the settings instead of just saying one turns it on. And if you see that the exporters don't match from your setting, you know it's not going to work. Don't bother attempting to do the crypto to generate an exported authenticator. Next slide. So, open issues that we want to talk about. First off, there's the question of how all these frame types get bound together. The draft has improved at explaining this, but it's still kind of a little network here. So next slide. The certificate request has a request ID. Certificate needed, because there can be multiple of those for various streams, point to a certificate request by request ID. You answer a certificate needed with a used certificate that's referring to the same stream ID, saying which certificate you're using to answer the request for that stream. And then that uses a cert ID to tie it to a certificate frame that has an exported authenticator. Now the interesting piece is, inside the exported authenticator, you have the request ID that that certificate is bound to. But it doesn't have to be the same request ID that was used for that stream. And the scenario where you would want to do that is you've gotten separate requests for www.example.com, image.example.com, and scripts.example.com. Well, likely you have one cert that covers all of those names. And it would be nice not to have to generate 3 separate exported authenticators for the same certificate, all responding to the same request, to different request IDs. So we allow you to say, I have already sent you this certificate, use it to satisfy that request. So right now the draft says that you need to dig into the exported authenticator with APIs that are defined in that spec, retrieve the request ID, and ensure that it matches some request that you have sent previously, but not necessarily the one on that stream. So next slide. Admittedly, that doesn't line up perfectly, but it's operationally a better choice. So there is kind of a question of, do we want to allow cross responses like that? I mostly think that we do, but it's not entirely clean. And then there's an open issue suggesting that the certificate frame should explicitly contain the request ID so you don't have to ask TLS to get it out for you. I'm open to opinions on that. I'm inclined to think that if it's already there and it's just a matter of asking TLS to read it, that's probably okay. But it does make a dependency on the TLS library to interpret them.
Would you like comments now, or do you want to
Yeah,
finish?
comments now.
Wow. Okay. Martin Thompson, I've always been a little bit sort of unhappy with the situation where we sort of ask a question and, I mean, indirectly, of course, we have to go asking TLS to give us the answer to the question that we should be able to answer directly ourselves. Mm-hmm. If that means duplicating the information, I think I can be comfortable with that. I like the separation between request identifiers and certificate identifiers. I think that's a useful abstraction that we can use, and particularly useful in these cases where, yeah, you get the css.example.com, images.example.com, what have you. All of that stuff is goodness, particularly when we're talking about something that's so grossly inefficient as certificates. But not being able to know which request was being answered without going all the way into the opaque blob that we just got out of TLS is quite annoying. So I'm inclined to say just duplicate it.
I will push back on one piece that you said there at the end, which is the request that is being answered in terms of the stream is the request that was sent for the stream. But that's not necessarily the same as the request that generated this exported authenticator in the first place.
That's the one that I'm more concerned about. The carriage of the blobs. If you go back to the picture, mm-hmm. The ones at the bottom I don't care about. It's the ones at the top. I mean, it's all indirected through the request on the stream and all that business, but fundamentally, you have to be able to. There's some magic that goes on. So say you have multiple certificate requests outstanding at the same time. Mm-hmm. The HTTP layer doesn't know which one goes with which until it's gone and talked to the TLS layer, which I don't like. Nick doesn't care.
Okay.
I was going to say we can bring the third co-author up and just sort of have an editorial meeting here.
Yeah. I would like to hear from other people on this one, because it's not a huge problem.
I mean, frankly, this isn't my presentation because Martin opened the issue. I don't agree with him. I would like someone to tie break.
Ben Schwartz, is it possible to send a certificate frame that just contains a reference, basically, to make an explicit reference?
That's essentially what a use certificate frame is. So you send a certificate frame that has the exported authenticator once, and then on every stream on which you want to use it, you send use certificate with just the cert ID. But then you follow the cert ID to the exported authenticator, and if you want, you can find the request ID of the request that triggered that exported authenticator to be sent.
Sure. So could you go back a slide? Or thanks. So use certificate doesn't have a request ID in it.
Correct.
So I guess the question would be, could you have a frame that's like certificate and like request ID and also a pointer, like here's the exported authenticators over there. So effectively, explicitly answering the request, saying like, yes, I'm answering your request. The answer is over there.
Okay. So far, the document has done that purely by matching them up on streams, but potentially we could add a fifth certificate type that says, yeah, we'll have to come up with a name, but basically responds to a request with an existing certificate, but not bound to a stream. Any other comments here, or should we?
Yep.
Kazuho, I think that well, at least I don't need the request ID in the certificate frame, and having two things that needs to be compared or validated to be equal is something that I'd rather not want to have.
That's a good point, that if we put the request ID in the certificate frame, then you still have to check in the exported authenticator what the request ID is to make sure that it's equal to the one in the HTTP frame. So you don't actually save the call into TLS.
Nick Sullivan. So yeah, you're saving a search, essentially. You're saving a search through all the outstanding certificate requests to find something that matches the request ID. That's why it would be duplicated, right?
Are you? Because you have to ask TLS to open the exported authenticator to give you the request ID, or you get the request ID out of the cert frame, but either way, you have to go find that request.
Right, but if you have the request ID in the certificate frame, then you have to also look in the exported authenticator to check the binding.
Yeah.
Martin Thompson, something occurred to me, but this picture is really good for that. We have the problem that Kazuho identified on the left, because the certificate request has the request ID in two different places. You want to fix that? Pick one. I don't actually care. Either you have two in both, or you have one in both, and I'm okay with either one. But it would be good to be consistent.
Okay.
If that's the case, two in both sounds fine to me.
All right, Sabode, last comment.
Yeah, Sabode, unrelated question on this particular issue. So if we're done discussing that, then. So I wanted to kind of get an idea of what the scope of the certificate certificate authentication is, for instance. Is it only for things that are applicable on this connection, or for example, does it extend the scope beyond this connection itself? For example, can we apply this to alt SVC, which may presumably be cached beyond the scope of this one connection?
So in the current version of exported authenticators, it is only for this connection. There is a proposal in TLS that would allow you potentially maybe to hook it into a resumption, but that's not true for the current draft.
Okay, thanks. Yeah, it would be, just make it explicit would be great. Thank you.
Okay.
You got 7 minutes left, Mike.
Okay. So then there's the issue that came up during I thought it was going to be brief discussion last time, that is actually kind of hairy. So next slide. The problem is that you can use secondary certificates to make various other forms of attack on a cert either easier or worse. So without secondary certs, if you get a misissued certificate, and let's say Mallory is trying to steal traffic from bob.com, Mallory has to get you to navigate to his site and get a misissued certificate that covers both his site that he induced you to connect to and the attack site. And if he does that, then if you're requiring certificate transparency, you have a record of that cert being issued and that cert covered both domains, and you have at least a breadcrumb of who to go after, as well as being able to revoke it. In a secondary cert world, those can be separate certs. There's no certificate transparency link between the two. The attacker still has to get induced navigation, and you can still revoke the cert when you see it in certificate transparency, but you don't have the breadcrumb to try and figure out who did that. Now, how strong a breadcrumb is that going to be, considering it was probably a throwaway domain anyway? Probably not very, but it's something. Where this gets a little bit hairier, next slide, is in the case of a key compromise, where they actually have the legitimate cert and the actual private key of that cert. In the current world, you either have to take over DNS or subvert IP routing so that you can steal the connection that was going to get routed to the real server and then present your fake cert. And the target of the attack is blissfully unaware, but there is at least some work involved in hijacking a TCP connection. With secondary certs, you're back to induced navigation, which we know is easy. And then you present the real certificate as a secondary cert on that connection, and the attacker is no less aware than they were before because they were blissfully ignorant before. But it becomes easier to do. So there was a proposal last time where perhaps instead of permitting normal certificates, because we should have a new requirement that certificates used by servers, this probably doesn't need to be done for client certs, but certificates offered by servers might want to have some kind of OID that says this is okay. Which kind of makes me sad from a deployment perspective, because it means all existing certs and all existing ways of issuing a cert that you have set up are not usable with this, and that's going to slow adoption. And also in terms of an opt-in, we already have the quote-unquote owners of the primary connection. They want to be able to control whether secondary certs are used on their connections. And now we're also going to have opt-in from the ones being coalesced onto those connections. We know that opt-ins are hard to get uptake on, double opt-ins exponentially more so. And just from an optics perspective, if we have an OID that says it's okay if you hijack my cert, nobody's going to do that. So we need to at least have some somewhat useful looking mechanism associated with it if we do this. I don't think a blanket in or out is necessarily the best choice. So next slide. I got an interesting suggestion during a side conversation on this that instead it might want to be a list of primary domains that this can be secondary to. So if you do steal the cert from images.macy's.com, fine, but it can only be used secondary to www.macy's.com. So unless you also have that cert, who cares? Or at least, maybe not who cares, but you are no worse because you can't use secondary certificates with it unless you have that primary cert as well. Honestly, I'm not wild about having this requirement at all, but I can understand the security argument that we need to do something to mitigate making attacks easier. And if we need to do something, this is the best suggestion I've heard. So I would like comments on whether we do this or none of it.
Nick Sullivan, this seems like it's even stronger of an opt-in because you have to opt into a list rather than opting into just one bit, which is yes or no.
You can opt into a wildcard.
But that's still, you have to, okay, so wildcard means anything.
Yeah.
So this is just adding, this is reducing the scope of the opt-in optionally.
Correct.
It's more complicated, or I guess more complex mechanism for limiting the exposure to this attack.
Mm-hmm. And I think there is some value in, if you are confident that this cert is probably not going to get stolen, maybe it's in the hardware security module and there really is no way to get the private key out, then fine, do a wildcard, throw it in, go ahead and use it. If you think the certificate is at risk, you can tighten the scope and reduce your exposure.
Ben?
Ben Schwartz, as an intermediate between these things, could you imagine a tag that essentially creates a pool? So like all certificates on a connection must share a tag, but we don't have to nominate exactly one of them to be the primary. Because otherwise, I imagine in a CDN type situation, it would be challenging to know in advance which certificate is going to be the primary, but you could mark everything in the pool with a shared tag.
That's an interesting one. So you put an identifier that's probably going to be the CDN you expect to use, or maybe your customer ID at that CDN, and then they all can be secondary to each other. That's simpler. I like that.
Yeah, I was going to say basically the same. This is Richard Barnes. I was going to say basically the same thing as Ben, that the tagging to the entry point domain seems really awkward for things like CDN. And something like this tagging thing seems way more sensible. I wonder, though, it seems like at that point you're kind of hinging some of your security on the difficulty of adding that tag into the OID. So I wonder if there's something to hook to, like something that's access controlled for that tag, like say an Acme account ID, or some other thing that's difficult to get. That might be external to this specification. It might be, the rules that say a browser form puts for what you put in that field. But, it might be worth thinking about what the security properties are, depending on how difficult it is to get that binding identifier.
Yeah, because the downside with the tag is that the attacker could issue a cert with the same tag if they're able to acquire it, and then...
an attacker can execute the attack if they can obtain a certificate that has the proper tag.
Right. So...
I have a different suggestion for that tag.
Yeah.
So one of the options might be actually to hash the straw man here, but hash the certificate itself, the contents itself of the primary certificate. So that means that not only binds it to ownership of the domain itself, but also ownership of the private key associated with the domain, the public key of the domain. So that means like you have to not only get a certificate associated with that host name or tag or whatever opaque identifier, but you also have to own a specific private key to be able to execute an attack on this particular.
But that seems like an even tighter restriction.
It's a tighter restriction, yes. But we're going with if we're doing some restriction or we're doing it like pretty tight, then that would mean that presumably the property we want here is that a server, like when you revoke the certificate that you have and the primary certificate, it would also, or you like destroy the key or something is gone or that certificate is no longer usable, the authentication properties of the things that are secondary to it are also not usable as well. So it seems logical to pin it all to that primary, not just a domain which is opaquely satisfiable by any private key.
But I think the property that Ben was suggesting here was that it's difficult to know which of several certificates will be the first one to trigger the connection. And therefore you want to be able to use any of them as the primary and the others as secondary. And if you're tying it to a particular private key, we don't have that property.
Right. So in the case of in this one, you have an OR case, right? It's a list, and any one of them can be satisfied. So you can create a graph of authentication with an OR as well, as similar to how you would do it with a hash, you would do it with a list as well. But you cannot. It's kind of you have to have a root, and after that you can have like leaves. But it does restrict you in that way. You have to have some sort of root. It's not exactly a graph.
Last call for getting in the mic line. Mic line is cut. Go.
Kyle, do you want to go ahead?
Kyle Neckritz. So rather than pinning to a specific tag, we could say pin to a specific CT log that all certificates in a particular set of shared certificates have to be in.
Okay.
So as I'm thinking about this more, I think the property we need here is that whatever goes in that extension needs to be something that a CA can verify in order to prevent issuance of certificates having improper values there, which kind of points toward, using a domain name there because that's what CAs are built to verify. And I think that may actually be good enough. So use a domain name as this in the same tagging way that Ben mentioned, so that when I go to Cloudflare, I get cloudflare.com in all the certs, because they have. And I think the rule you would say is the CA has to verify before the CA issues a cert with this extension. It has to verify, in addition to whatever it would normally do, that the applicant controls the domain name they're putting in the tag field, in the tag extension. So you'd basically be getting a certificate that says this, the server owns customer.com as well as cdn.com. Okay. And then you'd use the cdn.com one through everything else. I think that seems implementable. I think it gets the right security properties, and the security properties you're after here.
Okay.
I see a number of nodding heads out there.
Yeah.
So.
Okay. So that sounds workable to me. I will admit that in terms of doing cert extensions, I have no experience there. So I would welcome contributions of text.
It turns out one of Let's Encrypt's engineers is in the Acme session, in the Acme room, so I'll hook you guys up later. I thought he should be able to help with that.
Maybe excellent. A little ad hoc design team to kind of refine this design might be good.
Yeah.
All right, and
You're out of slides.
Okay.
All right, thank you, and thank you for the useful discussion, everyone. I think we're making some good progress, and yeah, it's not plugged into the laptop. I think that's probably the problem. Okay, next up, structured headers.
Cool. Oh. So structured headers. We've been working on this for a while now. We have, as I think we talked about last time, an implementation in JavaScript, a partial implementation in Chrome, because web packaging has adopted web structured headers for some of their stuff. We have a partial test suite going. Contributions are very welcome. I think overall, it feels like this spec is getting mature. We probably need to go a couple more rounds with it, but it feels like we're getting close to something that we would want to ship. And the big question in my mind is whether we've hit the right balance between, simplicity and capability, whether we have the right set of data types and structures to cover the interesting use cases. Yeah, so next slide. And in that spirit, there are a bunch of open issues right now. Most of them I think we can address on the issues list, but there are two along the lines of that. Does it work? Wow, okay. There are two along those lines that I thought it'd be useful to talk about here. One is that we've received some feedback from potential header users of structured headers that it'd be useful to have an ordered dictionary. So A equals B, C equals D, but where you can access that as a dictionary, as a hash, but also retain the order for that. And whether that's important enough to get into the spec or not is I think a question of judgment. I do notice that the newest version of Python makes ordered dictionaries the default, at least for CPython, which is kind of interesting coincidence. So we could take a couple of different approaches to this. We could require the existing dictionary object to be ordered. So a language like Python would be able to just use its normal dictionary data structure. A language that doesn't support ordered dictionaries, you'd have to do it with an object somehow. A little more abstraction. Or we could create a separate ordered dictionary or ordered parameter top level type in addition to dictionary. Personally, I'm a little reluctant to add top level types until we're sure we need them. Or we could say, no, we're not going to cater to this directly, and you can jam whatever you want to into the existing data structures. For example, you could have a really ugly param list where the identifier, like if the param list is basically like a list of MIME types. You have a thing, and then you have an optional set of parameters on it. You could say, okay, thing A is just a marker, then you put the real parameter after it, then B is the marker, so you retain your ordering, but you have this key value pairs. It's kind of ugly, but it could work with the existing spec. So I just wondered if anybody had any opinions about that.
Martin Thompson, these things are naturally ordered. I mean, we put them on the wire in a very specific order.
With comments.
So I think this is the sort of the default that we want to have. But it would be fine for individual definitions for header fields to say they're using this structure, but attribute no semantics to the order in which the items appear. And I think that's probably the right way to do this.
I tend to agree, and I think what we would do is have, and maybe we need a new appendix which says advice for APIs to structured headers, and that would be when you implement dictionary, make sure that you allow ordered and unordered access, so as a hash or as a list.
Yeah. JavaScript is ordered.
Yeah.
You can iterate in order, and it maintains that. So
this
is a common pattern that's coming up in languages. It's a facility that's being provided partly because you don't get interop on JSON without it in a couple of cases. So, yeah.
Anything else on this one? Okay. I think we'll give that a try and see how it goes. Number 629, identifiers. We removed identifiers from the item. So, we specify this thing called an identifier. In A, B, and F terms, it's roughly a token, has a few extra characters, but it's just a unquoted string. We removed them in issue 505 because we just talked about how do you distinguish between an ordered or an unordered dictionary in an API. The same issue was here. How would you distinguish between a normal string and an identifier so that you could reliably serialize the right thing based upon a data structure in some language? We removed identifiers from the item payload so that it would simplify the APIs so that you wouldn't have to have an object to wrap an identifier so that it would serialize correctly. If we re-edited them, I think that most languages would need to do that. And the driver for this is we got some feedback from Anna van Kesteren saying that he'd really like to have bare identifiers as payload so that he could backport potentially structured headers onto existing syntax and make it work a little more elegantly. Does anybody have any feelings on this one way or the other? To be clear, I was the driver for 505, and I think this is a reasonable feedback to add them back in. It makes the APIs a little more abstract. Now you need an identifier object basically, but I don't think that's the end of the world. Come if you're awake. Okay.
So Julian says this also depends on what characters would be allowed in identifiers.
Yeah, right now identifiers if I remember correctly, it's token plus a few characters. I think there's been a little discussion about adding a few more characters. We need to keep it safe and extensible, but also a bit flexible.
It'd be kind of nice if you could do base 64 or some variant thereof inside.
We already have binary. We don't need to go there.
Yeah, you wish.
Okay. All right, I'll take that on board. That's all I have for structured headers. Like I said, it does work. I think, we need a bit more time on this, but I'd like to ship this maybe around Bangkok-ish. I think that we don't want to leave it out there too long.
Right. So there have been 50 issues open, mostly closed. So it's actually got an input from a number of different aspects, which is always good. Can we get commitments from a handful of folks to review if we're on a Bangkok timeline? Looking for maybe 5 hands that will promise to read this from a core working group perspective. Excellent. I know who you are. Thank you so much for your contributions. Thanks, Mark. Kazuho, we're doing a cache digest next. So we've got, I think, 3 pretty quick updates coming here, and then we'll get into the proposed work session. And so folks can be prepared for the ordering there. I'm going to suggest that CDN loop prevention get this first slot simply because that's the only one in which the presenter himself has the conflict rather than folks who are interested in the work. So if you can't live with that, throw yourself in front of the microphone at the appointed time. Kazuho, go.
Yes. So this is about cache digest, and there hasn't actually been new updates. We released a new version following the consensus in London, and it was to remove the support for stale digest, and we've done it. And there was a pushback on the GitHub pull request, and that for REST API that serves a list of files, then it would be beneficial to have a stale digest so that the server can push the stale ones when the index is being requested. So we might reconsider this, but we don't need to hurry because there is an open issue that's been pending, and which is about changing to yet another better digest algorithm. And ultimately, we need something by a browser that works well on a browser and that's also compact. So Yoav is continuing his research to find the best algorithm, and I think we will rather wait for him than trying to figure out without having an implementation. So that is the status of cache digest.
Thank you. So we just intend to keep this open for a little bit, right?
Yes.
It's an experimental draft, so people are clear on the status.
Yes.
Okay. Does anyone have any comments from the floor about cache digest? Okay. Client hints. Mark, do you?
Yeah. So we just opened a working group last call on client hints. Ilya submitted a new version of the draft. We've held it open for a while because we wanted to make sure to coordinate with the fetch specification in the working group, as well as the HTML specification there, so that it was aligned with what we did. And I think that the folks involved all agree it's settled down enough where we can go ahead and ship this spec. So we opened a 3-week working group last call. Since we're all here this week and a lot of us are traveling over the weekend and next week, we made it a bit longer than the normal one. So please have a look at that specification. If you have any feedback, send to the list. Especially, this is an experimental draft, and we called it experimental because we only had one browser who was committed to implementing it. And so we're looking for interest in implementing it from other folks, whether it's browsers or server side. I know we've heard from some folks on the server side. And also, support for publishing it, interest in the general use case that it is designed for. So please take that to the issues list or to the mailing list. Or if you have any comments about client hints, now we've got a little bit of time in the mics. No. And Ecker's here. That's good. Okay.
It is. So we have one more active adopted draft to talk about, and that is 6265-BIS, the cookies restatement and update. I believe Mike West was going to try and join us remotely. Is he?
Mike, can you go ahead and request do the Meet Echo thing? Oh wait, I said Meet Echo. Now they're going to come. Oops.
Maybe they'll find Mike.
Yeah. There he is. Okay, here we go.
Hello. Is this working?
Yes. Yes, you do.
Oh,
Yes.
the joy of technology on the first try. Amazing. So, RC 6265-BIS, there's not a whole lot of progress since the last meeting. I have not had time to work on it. Happily, though, we have John Wielander from Apple, who's agreed to hop in as an editor to help me out. So I'm very hopeful that we'll have actual progress to discuss in a couple of months. There are a number of bugs open, a lot of those around the same site attribute, which is excellent because people are actually looking at the same site attribute. We have support for same site has shipped in Safari, Firefox, Edge, and IE over the last couple of months, which is pretty exciting to see. Because of the attention, we're actually finding bugs in the spec, which is great. We'll get those fixed, as well as fixing them in Chrome's implementation, which has been shipping for a while. We're also in the process of porting over the test suite that Adam Barth wrote a long, long time ago into the web platform tests repository that browsers are generally using as part of their continuous integration tests. We've got about 50 some odd of those tests ported over, and we aim to get the rest of them ported over now that Web Platform Tests has added support for multiple registerable domains, which took quite a bit of time. I'll note a couple of metrics just because I think they're interesting. Around this time last year, the same site attribute was present on 0.01% of set cookie operations that Chrome users saw. That's up about 5x over the last year. So we're up to about 0.05% of set cookie operations using the same site attribute. Likewise, the _host prefix was at 0.005% a year ago, and it's hovering around 0.01% right now, so about a 2x increase. The _secure prefix was hovering around nothing a year ago and is up to about 0.003% over the last month. So we're starting to see more usage of the things that are defined in this new specification. We're also seeing, as I noted earlier, more adoption of the items in the spec. So I think we have multiple implementations of everything that we've added. And as I said earlier, since John's going to join and help out with the editing, I'm hopeful that we can get through some of the disagreements between browsers and in the spec, resolve those in favor of the browsers, and call the spec done. Any questions or feedback?
Ecker, did you? No, you're done. Okay. Anything? Anybody? Okay. Well, thanks, Mike.
Cool. Thank you.
Thanks for staying up, and good to see you.
Yeah, and that sounds promising. Thank you, Mike.
Thanks.
Okay, so as I said, I think that ends the presentations we have on adopted work. We'll move on to some. We have 3 proposals of things people are interested to see if the working group feels are in scope and has the energy to work on. And we're going to start with CDN loop prevention because there are several conflicts with CFRG coming up, but that includes just one of our presenters, who is Nick. So, okay. So Nick declines to take the time, and so Chris's. We're going to honor Chris's conflict and have the SNI presentation next. If I've got that wrong, I can correct that too. But you've ruined my ordering of my tabs, so I just got to look around now. There you are.
It was working for me.
It is working.
It may just not like me. All right, so I'm sure we all are familiar with the various approaches to encrypting SNI. I know for me, saying something is the easiest way to submit it in my mind. And when I was a kid, there was a game where they would tell you something and then do charades. And I kept saying the thing they would tell me. And I just couldn't stop myself. And web browsers are doing the same thing. They say it even when they're supposed to keep it secret. And so we're trying to find ways to reduce that. And
use the mic. Yep. All right.
You get it closer to the
Yep.
mic.
well, now we're sure it doesn't work.
Okay. Never mind.
Good.
Yeah. All right. So the proposal in a nutshell is to add an SNI parameter to an alt service record to say for a given alternative, you can also suggest what SNI value you ought to use when connecting to that surface. And so you can pick something innocuous that you know is going to be in the same certificate, or you can pick a certificate you know the server has and then use secondary search to get the one you actually want afterward. But either way, you can pass this suggestion along with alt service and all the various ways to deliver that. So in terms of how you check that that first certificate is okay, which you have to do, you can't just follow what used to be there for opportunistic security and we took out before it went to RFC of discard the first certificate. Just doesn't matter. It actually does, because then an active attacker could induce you to connect and then see what secondary cert request you're sending as soon as you connect. And well, now it takes a little more work to find out what your SNI is, but you can still acquire it. So now the primary certificate on the connection has to be somehow related. It might be the host name that they gave you the SNI for. So whatever the innocuous host name is, it might be the host name of the origin, which is what alt service currently says, or it might be the the host name of the alternative that you listed in the alt service parameter. So if we're saying you can get www on alternate.example.com, the cert has to be for www or alternate, and if alternate cert does not cover www, then you'll ask to see it with secondary certs.
This creates a way to confirm, at least potentially a way to confirm where you're going, I think. But I'll have to think it through. Maybe I'm wrong.
Okay.
Having all three of those seems like extremely hard to think to reason about. Like, if the claim this says go to these guys, right? Like the alt service says go over here. Why am I returning like the original one? That's like not that's a confusing semantic.
Why am I returning what?
So I asked for a.example.com and I got b.example.org in the alt service. Like, under what rational circumstances should b.example.org be sending me the certificates for a.example.com?
RFC 7838, alt service.
Right. So alt service currently requires you to the alternative server to send back the original origin.
I understand, but he's going to send a new SNI.
So if I can insert myself behind you in queue, my confusion is that alt service requires the original origin, the origin host name to be covered by the cert, but it doesn't require the alternative to be covered by the cert. Right. And I can understand the SNI being added. That seems like, okay, if we're going to do something in this SNI's name, we should probably own it in some fashion. But why add the alternative to the mix?
So this is adding the alternative as an option. So when you're using TLS 1.3, which cert you're using is not exposed to the wire. This gives it a way to basically have a concealed option, and I think the
No, you can't do that because then they'll just cut and paste.
Cut and paste what?
That if you respond to the cover SNI value with the true certificate, then I just take the cover SNI value and send it to the server, and I get the certificate back. You have to respond with an innocuous certificate as the cover certificate. Now, it might be a star certificate, or it might contain both domain names, but if it doesn't validate for the original, for the SNI that you put in the client hello, then it's absolutely clear that SNI is a cover SNI. Like, why we spend all this effort trying to find the client hello, the client key share to the SNI in the first place?
Author privilege. So, Ben Schwartz, I agree with your analysis. Essentially, this draft it introduces a variety of modes, essentially, or a variety of combinations where it can be used. Not all of those modes provide the full level of protection against a probing attacker, basically. So, yes, if your threat model, the threat model that you're proposing is a reasonable one, if that is the threat model of a site, then they probably shouldn't use this in that mode. They should probably make sure that that they return certificates that cover the SNI that clients are providing.
But okay, I guess
so can I inject as chair? Is this aspect of the design crucial to meeting your use case? Because I don't want us to crater on this if you've got more.
I think we can tweak this, but
okay. So let's not hyper focus on this one part when you've got more.
Yeah. And I think also the scenario that this last bullet was added for was when the alternative is an IP, and so
it might be the must there that's confusing.
Yeah. Well, the must is it must cover at least one of them.
Okay. So both Angar. So I'm wondering why we're mucking around with the SNI itself. SNI has several restrictions. It must be like a ASCII character or something like that. I forget. And it must be a domain name. So it seems like all this other stuff is problems that are being created by the fact that you're multiplexing the SNI. Would it be possible to just eliminate the SNI usage altogether and use another extension instead of the SNI in the replay field? Or no SNI.
Okay.
Yeah.
So we're going to actually cut the mic line right here, Ecker, but we're going to reopen, just so they can finish the presentation. But we'll get it reopened, don't worry.
Questions for this slide, that's great. Otherwise, let's let them get their whole idea out.
Oh, sorry. So yeah, I'm not mucking around with the SNI value or changing the SNI value, just eliminating the SNI value altogether. Instead of putting it as an alternative SNI, like no SNI.
That's distinguishable on the wire from normal traffic. And an adversary who wants to block no SNI traffic can just block it. So that may not be as strong against an attacker who wants to force you into the position of sending SNI.
Yeah, that's true for ESD.
Right. So the primary point of this design is from the external wire image, it looks like a connection to the innocuous thing, overall using alt service potentially. But then when you get inside the connection, the client knows it actually wants some other certificate or some other host name on that certificate.
Eric Nygren, clarifying question and a response. Clarifying question, these are in addition to the it has to match the host header, not instead of? Because the last two break the security properties of alt service, which is if it's instead of.
So the primary certificate has to match these. And if that doesn't cover the domain you want to make a request for, then you need to get the certificate that covers that domain using secondary service.
Okay. And then the clarifying one is the other, like there is even just a simple use case for where you could do this, it's a wildcard case. If you have, there are quite a few sites that have a big covering wildcard cert, like star.github.com, and just being able to do _wildcard.github.com in the alt service is a very simple use case that could add a lot of value without needing to get fancy.
So are you suggesting let the client pick a
That was just
value?
in response to Subodh's comment on a case where this has value, even if it was even if we weren't doing anything fancy.
Okay.
To Subodh's point, the draft also does state that you can specify empty string, which means you don't use SNI.
You're pretty nice.
Okay. Okay, so we're switching. So there are two drafts here. That's one of them. The other one is DNS alt service. In principle, this is separate. So this is applicable. It's functional as a draft, whether or not you have any of this SNI munging capability in alt service. It just doesn't necessarily cover all the same use cases. So DNS alt service basically just gives you a way to distribute alt service through the DNS. It does the simplest thing you could imagine. There are some interesting subtleties here. One of them is that you can fire off a DNS query for the alt service and not wait for the response. If you want, you can just race ahead. And essentially the draft says that it's up to client policy whether the client considers it mandatory to get that information before starting the connection. Oh, well, no, go back. I'm not done yet. So a couple of new things that have happened here. We switched the order of the prefixes in response to a request from Martin at the last meeting. And thanks to a very detailed review by Schumann Hook in DNSOP, there's now very clear semantics for what to do if you have multiple of these things in an RR set in the DNS, and that's set up so that you can use this for load balancing within the DNS. So it's yet another layer of indirection that can be used for load spreading. Okay, I think that's enough. And this is a totally unfair slanted comparison of ESNI and our drafts, because I know that this has to be what's on everyone's mind. So one thing I want to add to this, in case anybody thinks that we're being too unfair, is in my view these drafts are they're compatible in a simple sense that a client could do both or one or the other, a server could do both or one or the other, and everything would work fine. But I'm really personally interested in ways that we could potentially combine them and basically get the best of both worlds.
Yeah. One thing that we've discussed is could we put the ESNI record in alt service?
Sure. So it doesn't matter if unfair, they're perhaps inappropriate or irrelevant, but we're not in competition here unless you're planning to send a letter for the HTTP working group to the TLS working group saying don't do ESNI. I'm not sure we need this comparison. I mean, the relevant question is, I don't think it's bad to have DNS alt service. I'm not sure it's good, but I'm not sure it's bad either. I think I'm like less persuaded that that alt service SNI that if you're in the environment where what you're doing is you're trying to go to like server A and you do DNS resolution, it's not clear to me that having having an SNI punt and then followed by secondary certificates is superior to having encrypted SNI. It's clearly slower and it requires an round trip.
Yes.
There's going to be like one domain in the marker, and so there's going to be one domain you're going to be showing. So it's going to be relatively similar in terms of marking properties. And also the thing is like basically. You're totally right, by the way, about like it's obvious what you're doing, but like basically when that one domain is like that one domain is like I'm the cover domain, like it's kind of obvious that almost everybody going there is the cover. And also, I mean, frankly, one of the things that made people sad about the various domain fronting debacles over the past 3 months was that someone's name got hoisted as like the cover name, and then those guys were under risk of selective blocking, and so I mean, this is why one motivates putting like a blank name in there. But then when you have a blank name in there, then you're like, well, I don't understand why I didn't do why I got out of that blank name.
Daniel Kahn Gilmore. So if you could put back up your comparison, I wanted to. There was a line missing there, I think.
There are probably several.
Yeah, so in particular, ESNI seems to be designed to permit a client-facing server to be distinct from the actual origin. And I'm not sure that that's the case for alt service SNI or DNS alt service. Maybe you could comment on that.
I think that is correct, that with ESNI, the server has the option to decrypt just the SNI payload, discover that it's not for that server and forward it on. Whereas with our proposals, you would have to terminate the HTTP connection and relay the request. You would become a reverse proxy.
So to be clear, in the alt service proposals, we're saying that the client-facing server gets clear text access to the traffic.
Correct.
Just to set expectations, we've got about a little more than 10 minutes left on this one. Kazuho?
Clarification question. You said that all this VCDNS thing provides new load balancing and DDoS defenses. May I ask how it's different from just sending a set of IP addresses in an address query? Because it's just sending a list of hosts rather than IP addresses.
Sure. So I'll mention two things here. One of them is that because the DNS alt service ties the alt service parameters, including the choice of SNI, to the load balancing selection, that is the choice of RR, it makes it possible to have to load balance or switch across destinations that behave differently. So if you have the classic example here is if you have two CDNs and you want the ability to load balance or switch rapidly between them, then you might need different cover SNI or different initial SNI for those two destinations.
But you could do that with IP addresses.
So you can actually do that with IP addresses in DNS alt service by specifying an IP address.
Yeah, my point is that then why do you need to introduce a new DNS record where you can do that with just an A record?
So you can't do this with an A record. That is, there's no way otherwise in the DNS to say, if you find yourself load balanced onto a particular destination IP address, then use this set of alt service parameters. But if you find yourself load balanced onto a different IP address, use a different set of alt service parameters.
I see. So it creates another redirection, you mean?
Yes.
Thank you.
Yeah, Eric Nygren Akamai. I'm decoupling the three things. I think alt service DNS is extremely valuable, and there are a lot of really good use cases for it, and I'm very positive on it. In fact, I think that most of my deployability concerns with ESNI go away, or many of my deployability concerns with ESNI go away if we use the DNS alt service record as the thing to have either a reference to the ESNI keys or the ESNI keys themselves, like the multi-CDN case it solves. It also means that you can kind of keep some of those TTLs potentially independent. The alt service SNI one, it may be that ESNI makes a lot of the use cases for alt service SNI go away. It may be that the wildcard label one in particular is one that's a simple enough case that's still having the alt service SNI attribute just to cover that one, so people could use that without having to go full bore. ESNI might be worthwhile.
We've got Patrick, Ted, and then Lutz.
Sure. Let me just respond to that briefly and say, I think there could be a possibility there where we say that, basically the secondary certificate case of this stuff is covered by ESNI, and so we use ESNI for those cases, and then we only need SNI replacement for essentially the cases that don't add a round trip.
So start with just a short co-chair comment, which is remember that we can consider these things independently, but we chose to present them because they obviously have implications for each other if you chose to adopt them both, right? So then as an individual, a lot of plus ones to what sort of Eric said. I think DNS alt service itself, very interesting. I'm interested in being able to know what the protocol negotiation is going to look like before the first round trip. That has a lot of actually really nice latency optimizations for the browser use case. So I'm interested in those. The SNI stuff, I'm very uncomfortable with how it impacts the core rule of alt service, which is alt service has no impact on how you interpret origin. And, there's some interesting complexities there around how the certificates are. I understand the actual rule is not violated, but it muddies the waters a bit, with particularly the discussion about the certificates. So I'm less enthusiastic about the working group adopting that personally.
Ted Hardy, before I start, I will note that you had two remote people in queue. I think at least one of whom was ahead of me. So if you want to do Lutz next, he would be ahead of me.
Okay.
I guess this is working now. So thank you. Yes. I'm Lutz Jacob from Bloomberg. I'm quite interested in the alt service SNI portion of this. I'm part of a group that is proposing a standard called trusted traffic. We have an internet draft in. And this would be very interesting for an origin to redirect authenticated traffic around a mitigation point that may be congested. We met last week with Ben also to discuss what we were considering. And this would actually be an interesting way for an origin to redirect a client to an edge network that can using some lightweight mechanism, validate the client and then forward it on to the origin. So we're very interested in this and seeing this proceed. For our use case, of course, publishing those records wouldn't be ideal because we may want to send a very specific edge to a client once we know that person is authenticated and trusted. Thank you.
Ted Hardy, I guess in part because of the green background to DNS entries are human readable and should not require frequent maintenance. Because to me that seemed like it needed a blink red behind it of like, oh, you lovely people that you think this is an advantage. It kind of worried me on a couple of different levels. One, the human readability aspect of it. There's a whole bunch of stuff in
Hold on. Sorry, Louis, could you mute? I think we had a little bit of a control issue up here until you'll be next after Ted. Thanks.
Okay,
All right,
so
Louis, get back in the queue, please.
The critical question really here is that if you think that the DNS human readability here and the less frequent maintenance will interact with people's attempts to use the DNS for redirection, I think that this turns into something where it's at best a white background. And if you believe that that's because everybody's going to use, IP anycast behind the specific names you're going to put in here, I kind of get that might be the case, but it really worries me that you think the human interaction with this record is important, and I'd like to understand why you think that's the case.
Okay. I guess in general, I think that somebody needs to be able to configure this somewhere, right? So to me, I guess the question is basically, do we need to create additional systems integration points where one of the challenges that I should be clear that I am a big supporter of ESNI. I think it solves my problem that I care most about really well. One of the challenges I see with it is that it creates an integration point between key generation somewhere in the TLS front end and the DNS, and that's an integration point that I think that has to be fully automated, because as far as I can, based on the discussion on the list, it sounds like those are supposed to be relatively short-lived keys, which means they're replaced pretty frequently. So that's a new engineering challenge that seems like we avoid if we basically have a static record whose contents is easy to understand.
Okay, that's a much better phrasing than that. I appreciate it.
Okay, the mic lines are cut now. We're almost out of time.
So I guess now I'm clearer on what those points are supposed to mean. So I think the assertion you're making is if you want PFS for the ESNI, then you have to regularly change the keys, correct? Because if you don't care about PFS for the SNI, then you don't have to change the keys like basically ever, right? I mean, now PFS is desirable, but it's not the only thing in the world. Yeah, okay. Like I said, I'm sort of trying to figure out how you envision this looking as a privacy measure. So first of all, I think, like, as Eric said, I am basically different the representation of like the ESNI keys and the DNS. If you don't think there should be an alt service record rather than like an underscore ESNI record, like I have no strong opinion. I guess, I'm trying to figure out what your sort of model about how this works is, because is your model the same one we're floating, that basically everybody in the everybody on the sort of CDN is going to use alt service to redirect to the this cover name?
I think basically that's where you wind up, whether it's a single cover name or whether it's a set of names that are associated with that cert. So the wildcard cert is a good example.
But doesn't that mean that basically everybody in the world accepts an extra round trip to get the secondary cert?
Not in the case of the startup.
Yeah, but like say Cloudflare.
Yeah, if you put a name in the cert that is not associated with the name you're actually making a request in, yes, 0 RTT turns into 1 RTT.
And 1 RTT turns into 2 RTT.
Yes. And that,
but I don't see how you get away from having those names. I don't see how you get away from having the names outside the cert. In this session wildcards. Like, so take a setup like Cloudflare where you have n domain names in the cert, right? Under what conditions is it safe to put like to put random to put like the pretend like what do you I don't understand what you put in the initial cert that like has any probability of succeeding.
So consider the case where the cert contains 10 customer names and Cloudflare. Then you can put one of those other names or put Cloudflare in the SNI and get back the cert You have to put something that would allow it to identify the cert, but.
No, I understand, but my point is like, so let's not say Cloudflare because I don't want to like implicate them. They're not like the people in charge of this, but you got a big CDN and it's got like 10,000 customers, right? And all of them serve alt service for innocuous domain X, we'll say cdn.com, right? So when I go and I ask for a.example.com and I get an alt service to cdn.com, and like how does the only thing the CDN can serve me is like the cert, which has like a 1 in 1,000 chance of having my domain name in it. So I understand how it works.
So basically, there are two ways that could play out. The first one is that you have a cert that is completely unassociated with the actual domain name.
Yeah.
And then you have the extra round trip for secondary certs. The second one is that you can use some other host name that's in the same cert. And then you have ambiguity from an observer as to which of the host names covered by that cert you're actually dealing with.
Okay, I guess, but I mean, that's like an enormous information leak, right? I mean, so there are the CDN is so I'm like an inspector, and the CDN is hosting 10,000 domain names, of which 100 are like really interesting because they're like cancer sites or dissidents, right? And so like. Then they have, as you say, they have 10 domain names per cert, which means that that the vast majority of the certs have like only 10 innocuous domain names in them. And so then when I get back one of those documents, and by the way, like these certs are not, you say these certs are not in the clear encrypted, but they're not, because all I have to do is take that SNI and replay it to the server, and I get the entire list of co-located domain names, assuming I didn't scrape it out of DNS. So like it's a huge information leak.
So if this is true, so first of all, ESNI is strictly superior in this case. I think I agree with that assessment. The thing I would say is this is not as impractical as you might think, because there's a small number of sites here, and if the choice is like disclose that the visitor is viewing my site, which is potentially dangerous in different ways, or accept an extra round trip, that's a choice that just that one domain owner can make without the rest of the CDN having to make any choice at all. That one RTT would be a big cost across a whole CDN, but for a single customer, that's a very small performance cost, I think.
Well, so again, I'm not trying to like draw comparisons between mechanisms. I'm trying to analyze whether this mechanism is actually a plausible mechanism, one we want to use, right? And I mean, it seems like yes, as you say, you could make that work, but it's like I don't see any scenario in which this doesn't involve an extra round trip. I see one, which is like some enormous domain which nobody's willing to censor, combined with like a very, very small number of like domains they're willing to co-host that are sensitive. And in that case, the certificate can contain like schmoogle.com and like the 7 things they're fronting for. But like it's really the only one we don't deserve a round trip as far as I can tell.
So yes, but there are other threat models to consider. So one of them is I am the only domain on my IP address. There is in fact no way for me to be confidential, but I can at least avoid explicitly leaking my identity on the wire. And instead I can zero out my SNI, and then I can try to basically hop IP addresses, and the IP address is all that's left to identify me, right? Like these are not cryptographic threat models, but they are real threat models.
So I'm going to interject here. We're not going to make a decision about this today, and we're over time.
Okay.
So I think this is going to be a great hallway conversation.
Sure. Okay.
Sounds good.
And list conversation. So we wanted to just get a sense of the. Do you have you're good, right? We want to get a sense of the group who is interested in continuing this discussion. We're not talking about adopting documents. We're not talking about any decision. Just who is interested in this discussion of continuing. I'm assuming that that's a yes.
Right, because this is the second time we've looked at this material, so we want to see if there's interest from the working group to continue, or if we just kind of need to move on in a different direction. So we're going to do 2 hums, right? One presumably with the simpler, the DNS alt service, right? See how much interest there is in that, and then separately, and I guess gated on the first one, interest in the alt service SNI, right? So you can call them hums.
Why, thank you. I've done this before, apparently. So if you, I'm going to be careful here. If you're interested in continuing this discussion of DNS alt service, please hum now. And if you're interested in continuing the discussion of alt service SNI, please hum now. It's fairly strong. Brad, you're putting the hum off of kilter a little bit there. You're very good at this. The first one I would characterize as a reasonable amount of interest. The second one just slightly weaker. Okay.
So that could agree.
No, because we're just gauging interest. Yeah. Disinterest is everywhere. Okay. Thank you very much, gentlemen. So next is CDN loop, yes. Yeah, sorry, we'd closed the queues. Thank you.
Hi, I'm Nick Sullivan. This is a draft that was put together in the last couple of weeks about a specific issue that has been plaguing a very small segment of the internet, but an important one. Continue. So as a background, CDNs, you can think of a CDN as a lot of different things, as something that's hosting static content, but a lot of modern content delivery networks are organized as a reverse proxy for websites, often TLS terminating, because customers can configure a CDN to point to an origin, and this origin can be anything. You can end up using CDNs in layers, so one in front of the other in front of the origin, or you can have them pointed to basically any IP address. In order to prevent a customer from configuring a CDN to have a reverse proxy that points back to itself through another service, they often implement specialized headers. There are some specific ones that are listed here that have been used to help prevent these loops. So because it's possible to point these to one another, and because it's possible to configure your CDN to modify headers along the way, especially headers that are multi-use or custom to a specific CDN, like some of the ones listed here. Next slide, please. You can get into a looping type scenario. Even if proxy 1 implements a special header that says, hey, I've been here before, don't forward me, proxy 2 can remove that header, and proxy 1 can remove proxy 2's header, and you end up in this infinite loop. This sounds theoretical, but next slide, please. Yeah. Sounds theoretical, and there was a paper about this, which was a theoretical paper, but it came with a practical implementation. And this has been confirmed. You can actually do this on basically the majority of the top 20 CDNs in some configuration or another. The loop can be 2 or 3 or 4, as long as you can configure one of them to strip out the dedicated loop prevention header. You can force them to do an HTTP loop, and this paper has some very interesting graphs and experimental results from this. So how are you supposed to solve this? Well, in HTTP, there's a header listed called via, which is meant to indicate that a proxy has forwarded an HTTP request. This via header is an example here. It lists the HTTP version and then a canonical name of what the proxy is. And you can coalesce if you see the same proxy multiple times, and you basically just append what you see on top of this. And so you shouldn't combine entries that have different protocols, but in any case, this is supposed to be the solution. Next slide, please. So in practice, VIA is overloaded, and in various web servers like IIS6, IIS7, Nginx, and Apache, which as of the latest records makes up, I would say, somewhere near the majority of all web servers, and web servers behind CDN, it's very hard to measure that number, but it's relatively correspondent with the public-facing numbers. There's an assumption that a via header indicates a proxy that does not support compression. So an HTTP proxy, so basically all the compression-related fields are ignored. So if you, as a CDN, send a request to an origin with a via header, it will reply back with a response that is not compressed unless explicitly configured to turn on compression. Next slide, please. So the proposal for this is a very narrow, dedicated request header called CDN loop. It has very similar semantics to VIA and is meant as a replacement for VIA that is actually practically deployable and can be used to prevent this. Next slide, please. All right, so the requirements here are that conforming CDNs should add a value if they are reverse proxying data, and they must not remove this header. So you add to it, you don't ever delete it, and as long as everyone agrees, then this header can be used as a common loop prevention mechanism. Next slide, please. This was posted on the list with a bunch of comments about existing other methods that may be useful for this. First of which is RFC 7239, the forwarded HTTP extension. There's some wording in here that may be a little bit ambiguous. I wasn't able to interpret it fully, but basically you can, it says in section 4 that you can remove previous forwarded headers. This is something that breaks the required semantics of what we need for preventing loops. The other proposal is from HTTP, the max forwards header field. You could basically set a max forwards field and decrement every time that you go through. So eventually you would decrement down to 0. But this field is mostly oriented towards trace and options, and its use in GET is not something that is widely agreed upon or implemented. And that's basically it. So this is a proposal. It's a custom header. It has a dedicated use case, but it is one that is it's useful for a very practical attack. Let's open it up for questions.
Got a few minutes. Go ahead.
Yeah. Clinton Thompson. I made some comments earlier about the privacy aspect of this, but looking at the alternatives here, the alternatives are far worse. Because forwarded says, yeah, I forwarded it for that guy. Specifically identifies them. VIA is pretty similar on that front as well. So I think as long as you're using some sort of generic opaque identifier that only the CDN itself is going to consume, then this seems about right. It's unfortunate that we have to do basically the same mechanism as another one. But, you know, welcome to the internet.
Piotr Sikora, Google. So I think the forwarded header is actually better use case here.
Can we go back one?
Even if we just use the by field, that would be, you know, forwarded by Cloudflare, forwarded by, you know, Fastly, and so, etc., etc. As a side note, contrary to what Martin says, I think all CDNs already include the connecting client IP anyway. So this way, if multiple CDN providers collaborate, it could actually be useful chain that actually propagates the client IP all the way to the backend, which I think has value versus stripping it and, you know, adding the last hop in CF connecting ID or IP or other stuff.
Leif Edström, Apple. So reading this draft, it kind of reads very much sort of targeted towards cross CDN loop detection.
Yep, that's the specific.
I kind of feel that it's much more generic than that. It could also be used inside a single CDN, right? Let's say you're doing cache hierarchies, child parent proxies, that sort of stuff. And your example kind of shows where you put in the host field as a parameter to one of those things. But I really think that it would be better if the spec would be generalized such it can be both cross CDN and sort of intra CDN detection.
I think we already have mechanisms for intra CDN. I mean, this is why there's loop detection headers that are used inside of CDNs. And generally, if you understand your infrastructure, you will not get into this situation. This is really about multiple independent
configurations from customers that can strip headers. And if you're inside a CDN and you have this complicated set of proxies and some of them are configured to strip the looping headers, then you really have a misconfiguration in your CDN.
No, that's not the point. My point is that, I mean, instead of having two headers, so right now we would do, say, via header to detect intra-CDN loop detection. But if I can do this all with one header, why bother doing both, right? That doesn't make any sense.
So I will note from the chair's seat that some flavor of this comment was pretty common in the thread in which you introduced this work. I will also note it was kind of nice to see 25 entries about someone proposing new work. So there is some interest in the space, which is great. My question to the authors would be, if the working group were to adopt this, would the resolution of this question about scope be something we would consider a consensus item for the working group to decide, or is this just something we should not adopt if the working group can't decide that beforehand?
Mark Nottingham is author. I'll say what I had to say before I answer that question specifically, because I think it'll inform it. This is a very specific problem. I know we all as engineers have this urge to generalize and to make things more generally applicable, and that's admirable. But as Nick said, we have CDNs where customers can configure to strip or add headers very flexibly. That is a feature that we all like to support and that we need to support. And if we reuse forwarded, or we reuse via, or we reuse something that can be used by other intermediaries, then it becomes not a specific targeted mechanism for how do we avoid loops between us and Cloudflare and Akamai and everyone else, to something that there's ambiguity about whether or not it's going to work or not. We really need this to work. The attacks here are interesting. So to answer your question, without talking to the other authors beforehand, my sense would be that if we can't get to consensus that we want a targeted mechanism here, I'd probably want to go somewhere else. Because it's more important to me that this works and that it's simple for us to implement, and we don't have any special handling around a header that a customer might want to touch for other reasons than it would be to have a general mechanism.
Kazuha?
And to add one thing, I would love for the people who want a more general mechanism to articulate why this proposal causes them a problem, why they can't live with it, rather than just the urge to make it more general.
Kazuha, I think the must not modify requirement is a very good thing, because most web application programming APIs are designed to allow applications to modify headers in any way, like Whiskey or they are all designed in that way, and that's causing the issue that via headers getting dropped or forwarded header getting dropped. So it's a very good way to say that there is a specific header that must not be exposed to a web application programming interface that could be modified, but rather the web server side could have it and then forward it. So I think having a specific header is a very good approach in terms of web application programming interface. And I support it.
Last call for the mic lines.
Eric Nygren, big +1 to what Mark was saying around value of having kind of a specific header for these sort of semantics. I think also on the how much to generalize is to also cover the within a CDN case. Some of that gets proprietary enough that could bog us down forever. And I think having the value of having something standardized is to really work through the issues of how different CDNs are interoperating. And if a CDN wants to go and include kind of extra hops within this, that's up to them. But I don't think that. I think the key thing is getting that between parties thing worked out.
Mike Bishop, I will echo both of the previous comments that I think the real novel and useful piece here is that it's a header that must not be removed. That what is causing all the other things to fall down is that they get removed and that customers want to remove them. And I hear the concern that if you use it for intra-domain things that customers might also care about, then customers might start demanding the ability to remove it. I'm not as worried about that if it's defined up front as must not remove, but okay. And I don't think there's actually anything that breaks, though, if you allow a CDN to kind of internally say, oh, we have effectively 3 sub-CDNs within how we handle a process, so we're going to add 3 tags. Okay, that doesn't break anything. But the important thing is you don't use it in any way that might incent a customer to challenge you on the must not.
Yeah, likewise.
We're going to need your name for the minutes.
Chris Lemons from Comcast. The internal to the CDN, we can use whatever we want. We have lots of options. And in fact, the existing solutions work quite well. But again, we need something that must not be removed. And making it simple, making it straightforward, making it not useful for a whole bunch of things does in fact incent people not to remove it and should help with compliance. And so I am very in favor of looking at this work.
So to address Mark's question, why forward and not this specific solution, my argument here is that it actually can provide useful information to the end user, so like the IP, and this is opportunity for CDNs to collaborate and come up with something that works end to end, kind of.
So, Piotr, is your assertion that forwarded along with this header is not a good idea?
No, I'm saying that forwarded instead of this header would be more useful idea to the end users.
Without the must not remove.
With must not. Or either.
Do you want to add must not remove to the forwarded header?
No.
I don't understand your proposal.
Just my proposal is to use forwarded header instead of the CDN loop, right? And like saying in additional draft that RFC that you must not remove this header doesn't mean that everybody will respect that, right? If we want to be realistic about this.
Mark Nottingham again. I think the real value here is that it's not only it's must not remove, it's that it's for an incredibly specific purpose. So if you're not interested in that particular purpose, then you don't really have an incentive to remove it. If it's used for other things, you might have another reason that we don't know about right now to remove it. And that's why reusing forwarded is not a great idea, in my opinion, because people are already using it for other things, which we don't even know. If it's just carved out for the most specific thing possible, then there's less likelihood of accidental or reuse or diverging use cases. And that's why this is so incredibly specific. So if you want the properties of forwarded, use forwarded. That's great. It's already there. But that's not the properties we're looking for here. We're looking for a different set of properties, which are a little bit subtle, and that's probably why this is a bit of a back and forth. Stepping back, I would ask the working group to consider, we have on this draft 3 CDN vendors who are all pretty highly engaged in this process now. And they've come, I think this is the first time we've done something specific to CDNs. Usually our engagement is about more generic things. I would love to get a sense, and maybe not here and now, but for the working group to start thinking about if we have other things that we want that are CDN specific, because the CDN is becoming, for better or worse, part of the architecture, and I'd like to see them become more interoperable. Is this a place we bring them or not?
Okay, setting aside.
Now we'll go up here and put on a different hat.
Right. Now you can judge a hum for your own document. Okay. So we will do, I think, one hum here about whether or not there's interest in us issuing a call for adoption. That's something we're going to have to do on the list, no matter. But if we get a strong indication here that we're interested in working on this document, which is a proposed standard, so it's an obligation of the working group to spend their time and energy on advancing it quickly and correctly, we'll issue that call for adoption. Okay, so the caveat I would have here is that we're going to adopt this document, and we're going to adopt this document, if we choose to do so, specifically within the scope of the CDN question. And if that, is not an outcome that's acceptable to you, you should hum against at this point. So those in the room who are in favor of issuing a call for adoption and working on the CDN loop draft, please hum now. And those opposed? Well, all right, almost unanimous. Thank you.
Julian, did he get in in time? I don't know.
Julian, if you want 30 seconds, we don't know when you got in the queue, so we'll.
Hello there. So you ignored Roy's and my comments on the.
Julian, we
can't understand you.
Maybe you got to go Jabber.
Can you go Jabber?
He has gone Jabber. I missed that. Go.
Okay. Martin's going to channel you.
If that's all right. So Julian says, I don't get why it's less likely that somebody strips the new header field as opposed to via. And Roy says, via already works. All you need to do is define a CDN-specific pseudonym and don't allow those to be removed by CDNs.
Okay, I think these are points we'll address during the call for adoption discussion.
I agree.
Okay, thank you. So next up, Helium. Lucas is going to present for us remotely. Lucas, we are about 5 minutes behind, so if you could make up half of that, that would be really excellent. Do we need to press a button to make you go?
He's not a button person.
All right, you're on.
Oh, sound?
But you're muted?
Can you say something, Lucas? Nope.
Hello?
Yes.
Yes.
Okay, great. You have to push 2 buttons. That's good to know.
We went out of order.
Okay, I had a lot of slides that I tried to compress down, so I need to compress down further. So forgive me if I rush through this a little bit. I'm here today to talk about network tunneling and whether there's space effectively for or solving the problem of UDP tunneling, mainly for HTTP over QUIC. And if we're going to go to that length, whether we want to expand the problem and solution into something more generic like IP. So there are 2 drafts here that I'll cover. One is called Hint, which is something I prepared to look at the general problem and solution space. And there's another thing called Helium, which is a draft by Ben Schwartz that was presented at Dispatch earlier in the week. So I'll explain these in a few slides, but first of all, I just wanted to frame the discussion and kind of baseline on how tunneling works today. So next slide, please. So what we have here is HTTP 1.1. Don't pay too much attention to the 1 bit. Just imagine it's okay and it's not H2, which I'll come on to soon. This is not transparent proxying. This is a HTTP 1.1 client on the left, trying to issue a request to the server on the right, and being configured to go via a proxy. So you can see here there are 2 TCP connections that's formed, and the proxy takes on the role or the responsibility of forwarding that on, and it may be able to filter requests or enforce any policy there. So that's okay, but we don't live in a plain text world now. So if you go on to the next slide, please. We've got here HTTP 1.1 over TLS over proxy. So what we need to be able to do is create an end-to-end TLS tunnel. So this has been specified. We have a new method called connect that we pass in a name to. So this example.com server, and that controls the creation of the TCP connection from proxy to server, and the client then can create the end-to-end TLS context and issue its request there. This is typically configured with something like a HTTP proxy variable or something like that. Just to highlight on the right, this is kind of a protocol stack view from the client perspective of things. So if we go on to the next slide. This is HTTP2 over TLS, so you'll notice it's not too dissimilar. We still have a client that's able to issue a connect request here on TCP. You'll notice that it's still a HTTP1 proxy. So actually, we're able to mitigate version here and still use this HTTP-based initiation mechanism to create an end-to-end TLS context that we can then do HTTP2. We negotiate that, say, using ALPN or whatever. But you'll notice the addition of a yellow box, which is here a HTTP2 stream. So this indicates that for a request-response exchange, we are consuming a single stream. So next slide, please. This one gets pretty complicated. So I appreciate people maybe aren't so familiar with Quick, but if Quick effectively inherits the HTTP2 definition of how Connect works. So in this case, on the left-hand side, we've got a UDP association between client and proxy. This is theoretically possible. I'd love to know how many actual deployments of this there are. How you discover that proxy is interesting. Do you use something like alt service, or do you set it up using some proxy pack rule, something like that? But regardless, you would issue a connect request on a Quick stream, and that would reserve that stream to then carry all messages from the client to the proxy that would then get unbundled from the stream, say, and forwarded on via a TCP connection. So what we have here is a single Quick context plus a TLS context in the same UDP association, and we have streams within streams. So that Quick stream is a reliable byte stream. It can be affected by header blind blocking. So any multiplexing of the HTTP2 streams within that TLS session would be affected by the Quick header blind stream blocking. So you don't necessarily get some of the benefits of multiplexing, but you do get the ability to connect out to the internet, which is possibly more valuable. So next slide, please. So this got me thinking, how can we do the same for Quick from the client to the server? Can we create a UDP association from a proxy to a server? And looking around, doing some research, there was no kind of standardized way to do that by a HTTP proxy. There could be some options here in terms of using Turn or SOCKS 5 UDP mode. I'm sure that is used in some cases. But hypothetically, what might be neater or nicer is to, if you go on to the next slide, have an ability to have something very similar to the TLS tunneling case that would allow us to do end-to-end Quick tunneling. And you can see there's some red question marks. Is that a connect method? Is that some of the new HTTP Quick extension? And this is where I began thinking about the problem space. So if we go on to the next slide, the draft HTTP initiated network tunneling is a generalization of connect-based tunneling. So this concept of converting either an entire HTTP connection or effectively stealing the TCP connection from out underneath the feet of HTTP, or some part of it, i.e. the streams, and converting that into something that can effectively be a TCP, UDP, or if there's interest, an IP tunnel. So that document presents a concept and other design considerations in this space. So if we want to provide a solution or design one, does it need to cover multiple HTTP versions, or is this something that could just be for HTTP Quick? We need to consider things like proxy discovery and its ability to chain. That's quite a powerful capability here. And is that required for the kinds of interactions that we might want to do for UDP or IP? Something here I kind of glossed over earlier is the ability to have agile targets. So the Connect tunnel focuses on one server. There may be lower level balancing underneath, but from the application layer perspective, we have one tunnel and it's going to one place. So would there be interest in having an ability to target different origins? Is more agility. If we're doing message-based tunneling, we need to consider path MTU. TCP avoids that issue, so this is something to consider. We need to think about the proxy's role in whether it manipulates messages as they go through, or does it behave like Connect and it kind of blindly forwards things back and forth. Hole blocking, I've already mentioned. And one of the main motivating cases for all of this work is the ability to kind of mask traffic within a HTTP connection and pad it out for traffic obfuscation. So the ID canters through all of that. It weighs up some options, some of the pros and cons, and provides some technical proposals, not fully complete, but more indicative of how things could look. So we need more input before investing any more time in any one particular one. Next slide, please. So yes, I kind of broke things into two areas: the initiation, whether we use a request method or some new H2 or HQuick thing, and then the transfer, the steady state framing of messages. Do we reserve a particular stream? Is this not even stream level and it needs some additional capability of something like Quick? So there's a lot of variability there, lots of permutations, lots of different ways to skin this cat. So just to help direct some discussion in kind of extremes, there's a spectrum of proposals in that document. One is, can we just take Connect and augment it in some way? Can we create a new method like Connect, but clearly separate from TCP for, in this case, UDP, and have some kind of new framing? Can we use something called Helium, which I'll explain on the next slide, and carry that over WebSockets? Or could we go the next level and have some native framing for HB2 or Quick that helps realize better benefits there? Next slide, please. So this is the Helium draft. This is Ben Schwartz's document. He went into a lot more detail in dispatch. This is Helium in a single slide, a lightweight, flexible proxy protocol based on IP, designed for many use cases. Forward and Quick is the one I've mentioned here, but you could do things like WebRTC, UDP proxying with ICMP support, go the whole hog towards VPN. The concept here is kind of abstract message types and then a concrete realization of that. And the document contains one which uses CBOR that runs over WebSockets, but we could also possibly natively frame that, and that's captured in my document. Next slide, please. So in closing, we need to be fully acknowledging of the fact that there are many ways to do UDP and IP-based network tunneling. HTTP-based or initiated tunneling has some unique benefits in comparison to those. And some of the discussions we've had leading up to this is that there seems to be interest, but is there enough interest in the community that warrants more time and effort? And if so, some input or guidance would be required for us. Can we actually drive towards one of those solutions or permutation of those two options? The things we're not considering. Does this work actually belong not in HTTP at a lower layer? And that kind of then relates to what is a suitable home in the IETF for this work. So that's it. Are there any comments or questions?
All right, we're running short of time, so if you want to get in the mic line, do so now.
Ben Schwartz, Helium was well covered in dispatch, so I want to encourage people to focus on the problem statement and not that particular component of the solution.
Line's cut.
That was a short last call. So I will comment that I like the architecture and the problem statement here, that being able to use HTTP over Quick to talk to a proxy has its advantages. And I believe that one of the previous interims, Google had mentioned they had, at least for some purposes, HTTP over Quick proxies with Google Quick. And we're seeing benefits from that. But the fact that you can't then do Quick past the proxy, I agree, is a problem. I like the division here of having something that is effectively HTTP layer. I'm now going to send some other protocol. And then that protocol being a transporty thing that's really an encapsulation. It's like an evolution of GRE, maybe. So I like that piece. I don't know that they belong in the same working group. If we do the HTTP piece here, I don't think we want the transporty piece. If we form a new working group that handles this problem, then maybe it could do both. And I think we don't know what way would be best. But my opinion would be we don't want to do and try and pick up the whole problem in this working group.
Briefly, the one thing that I didn't see called out here that worries me a lot is how when you start doing this sort of thing, congestion controllers start interacting. It seems like there's a lot of transport stuff under the hood here that gets very messy quickly, like running quick in quick. What? Okay.
Yeah, that's a great point. Some of those issues came up in the dispatch session, and that's something I hope to capture better in the design aspects. It definitely needs more thinking.
But kind of on the meta issue, I think it would be worth. May also feel free to skip. It was covered heavily in Helium, and dispatch, is we should be really clear on why we need something new here. Like it seems like a IPsec over UDP covered a lot of the use cases here without requiring inventing something new.
Okay, thank you.
Jana Iyengar. So I'm familiar with one use case where, as Mike mentioned, something similar to this has been used already at Google, and that's actually been very useful because being able to switch the last mile link from TCP to Quick allows for a lot of benefits because you can do better loss recovery and things like that on the last mile. And so it's quite useful to be able to run a proxy in the cloud, so to speak, and have the clients be configured so that they can speak quick up to the proxy and then TCP out the back of the proxy to the origin. So it's definitely useful. I will echo what Eric said, and there's one particular design assumption in Quick right now, which is different from TCP and TLS in that the transport and the crypto context are not separable. And this is right now, Connect assumes that they are separable, right? We have two TCP connections that can be composed and one TLS thing that can be layered on top of them. That is no longer true in Quick. We really can't get that kind of composition. So you would have to do TLS and TLS effectively. That's something, again, I mean, I think this problem is worth thinking about, but the pieces might land in different working groups and might actually trigger some interesting work. So yeah, I think this is useful.
Okay, thank you for the presentation. We did cut the line there.
The dispatch chairs have requested discussion happen on the dispatch list, so I would just mention that you might want to join the dispatch list if you want to talk about this more. I'll also ask the chairs to think about it.
I do understand that, and to the extent that we are introducing and modifying HTTP mechanisms.
Fight in the hallway after the meeting.
There's going to have to be multiple,
Dispatch versus HTTP chairs, we're going to kick their ass.
There's going to be, or there could be multiple discussions, have it your own way. I'll take you in the fight with Murray any day. It's all right. So we will take further input, particularly on the HTTP aspects of this. And I do want to reiterate one thing I said on the list, that if you operate systems that use the connect method, implement systems that use the connect method, that kind of thing, particularly in a forward proxy scenario, this would be a great time to speak up, because I think that's sort of underrepresented in this discussion, or perhaps it's not underrepresented in this discussion, and that itself is a point of input. Thanks, Lucas. We're going to move on. We're going to talk a little bit about H2 push data from Yoav has done some work that he wants to share with us. So this is a bit of an initiative to find out how some of the things we have standardized are playing in the wild, and how that works out. You are not Yoav. Hi.
Well done. So I'm not Yoav, as you can tell.
Wait,
but he's
clicker.
I think he's remoted in. So my name is Amin Natter. I am engineering manager at Akamai, and I'm here to. Yeah, sorry, I'm not as tall. I'm here to share some results about H2 server push. And this is over a period of 11 days. We had collected some measurements and had done some analysis on it from June 14th to June 25th. So at Akamai, H2 server push is primarily provided through a product called Adaptive Acceleration. And so what this product does is it analyzes RUM data. So this is real user monitoring data. So data that is based on nav timing and resource timing data is beacon back into data warehouses, where we do some analysis and determine what the critical resources are that are necessary for rendering on a given page load. And so the idea is that once we've identified these critical resources, we push them during the HTML generation think time. The advantage here is that the key is that we want to utilize the idle network time from when the page is being fetched from origin, and also bring back the TCP slow start. So looking at kind of a typical case where we're not applying push, the HTML request is generated, the request goes to the edge in a content delivery network, and then goes on for to origin to be fetched. And this is where we have the idle network time. And eventually the response comes back, and you can see the TCP slow start in effect, so chunks start coming back and getting bigger. And finally, the browser is making requests for page sub-resources, CSS and JavaScript, for example, and then those get fetched down. So the way that we utilize push effectively is to take advantage of that idle network time. So we want to be pushing down CSS and JavaScript that's critical to rendering of the page during the time that the page is being fetched from origin. And so we're using that, essentially that dead kind of time to good use. And you can see, theoretically the TCP slow start comes into effect earlier, and by the time that the HTML pages comes down to the browser, that hopefully we've moved past that phase. So Jake Archibald wrote a great blog post about HTTP2 push, saying it's tougher than we thought. And he has quite a long post that goes into the nuances of H2 push, scenarios where it's more effective, scenarios where it's less effective, the differences between browsers, how the caches within each browser work and vary from between them. So it's a great post. I recommend that you read it if you haven't yet. So diving into the results now. So just to give a preamble before I show the graphs on how to interpret this, we measuring DOM complete time in this case. And so when you look at these graphs, negative is better. This is a relative difference between H2 push on and H2 push off. So the further to the left that you see the bar, the better it is. This is Chrome only, and this is only first view only. So this analysis is based on measurements only on first view. It excludes repeat view on purpose. And that's for a couple of reasons. One is that the repeat view case is not that effective with push right now because of the absence of cache digests, for example. And with adaptive acceleration, we try to avoid pushes on repeat views for that reason. The difference that you're going to see is going to be a bar with min and max values. And essentially this means that we are 95% confident that the performance difference will fall within this range between the min and max. So essentially, when you see green, that means it's statistically, that's faster. Red would be slower, and blue would mean there's no statistical difference. Okay, so what you're seeing here is mobile results only. So hoping your eyes are not bleeding looking at this, the bars are kind of thin, but in this case, there's 11 results shown. So what we're seeing here is actually the intersection of some websites that are using adaptive acceleration product and also using a new RUM engine that Akamai provides, which is based on the product Impulse. And so it's the intersection between those products, and I mean, we are just transitioning to this new RUM engine. So the initial customer base is small, but it's growing. And we hope to be continuing to measure it based on this engine. So we use the nav timing metrics to fetch the DOM complete time in this case. So really, in this case, there's 11 results here. 4 we can prove they're statistically significantly faster, and 7 we can't say at all. And I have the raw measurements on the side that you can see on the left that provide the confidence interval and the mean. But for the blue ones, we're not supposed to derive any kind of conclusion from it. You might see the bar more on one side versus the other, but talking to our statisticians to say, no, you can't say based on that. It has to be completely on one side or the other to derive any kind of conclusion. So here we have 4 that are better, 7 we can't say. And you can see that the confidence interval is fairly large here in many cases. For desktop, we have 13 results and we have 6 that are better and 7 that we can't say. Now the scale is kind of shifted linearly a bit and maybe slightly in terms of magnitude, but you can see that the bars nevertheless are much shorter in the desktop case than mobile. And why is this the case? It's just because we see more variability and noise in mobile performance data. So there's more variability, presumably due to more variance in last mile networks, and that's reflected in the measurements. So it's harder to get statistically significant results in that case. Other results were we did see a statistical difference. We're seeing positive improvement with H2 server push applied. How did we measure? So statistical methodology, we're using a linear regression methodology that's used for statistical calculations, and it's based on following dimensions, so geographic location, client OS, user agent, hour of day, day of week, ISP, URL. This is all very important because if you don't try to control for these variables, you get too much noise, and there's several dimensions that can introduce variability into the results. So A/B measurements are actually quite complex, especially using real user monitoring data. And that's part of what we're finding as we go through this exercise. And again, so I talked about the set of customers that are used in this case so far. So we've split into desktop and mobile, restricted to first view requests, top 10 URLs for each customer website, minimums, and a minimum threshold for hits that have H2 server push applied. So what are we going to do? I think we're going to continue to gather data as a set of customers expand, and we'll report back later. What we've seen so far is that server push is it's a powerful tool in the tool set when used in the right circumstances.
So thank you very much. And I've asked people to hold their questions because we have a similar presentation from a different point of view. We wanted to make sure both of you could present before we run out of time. And then you can maybe address questions together if for whatever we have left.
You to combine Q&A after?
Yeah, after we do.
Stick around.
Yeah, don't go far.
I thought we were going to get all the questions out for him first.
No.
Hi, everyone. Brad Lassie, engineering manager at Chrome. So we also were interested in how push is performing in the real world. So first, a couple of stats. Right now, we see 0.04% of HTTP2 sessions that have a push frame in the entire session. That's not per navigation, that's for the entire connection. The average amount of push data in those sessions is 32 kilobytes. After reviewing this data, we realized that more useful stat would have been the size of the pushed resource. Maybe we'll make that edit later. Some other stats, when we see these pushes, 63% of them are successfully accepted, 23% or 22% timeout, and 13% are duplicate URLs, which mean that the same URL was pushed in the same navigation. There's some other noise for several other failure cases. So we ran an A/B/C experiment. We compared disabling push by sending the settings enable push setting set to 0. And we would still process the push frames if they came. This was purely just sending the setting. We compared that to no treatment, regular control, but we also compared that to sending an unrelated settings change to see if servers were mishandling HTTP2 settings. The dev canary data was too noisy to draw any conclusions about push, but we did satisfy ourselves that the servers were handling the settings frame properly, so we didn't need to include that control when we propagated this to beta. Within the beta results for the entire population, or sorry, the entire test population, we got a slightly negative, non-statistically significant result. So the best way to say this is that for the entire population, push makes no difference in performance. That's rather unsatisfying either direction. So we attempted to correct for that by removing the noise of servers that don't push. So filtering by domains that, according to HTTP archive, pushed when they were recorded in that crawl, we do see across the board improvements by disabling push. And all of these percentiles are statistically significant. And now we get away from the data-driven part of this presentation. So this is wasn't intended to be so scientific looking, but this is basically the idea of what is the...
Can I ask a clarification question on the previous slide?
Yep.
So the latency of the page is reduced when push is disabled. Is that what this is showing?
Yes, this is time, sorry, I should have mentioned this. This is time to contentful paint.
I see. Okay. And the control does not have push disabled. It's actually push is enabled with max concurrent streams.
So blue is push enabled, red is push disabled.
Got it. Thank you.
Lower is better.
Yes, lower is better. So this is basically just trying to describe that absent server think time, or the maximum benefit of push is either the amount of data you can send in one round trip, or your initial, well, the maximum data you can send in one round trip, which is either calculated by your bandwidth, your round trip time, or your congestion window. And I've heard some people argue that in emerging markets, this is an even more important thing because of the large round trip times. The interesting thing was when you take a couple samples, it all turns out to be about the same amount of data you can send in one round trip, just that round trip takes longer. Of course, all of this winds up getting, if it's the start of a connection, capped by the initial window, which if you're obeying IETF recommendations is about an order of magnitude lower than that round trip data, other than some people who are getting aggressive. So one of the questions that we have is if we were to turn off push for everyone, would anyone really care? Currently it's, as I said, only 0.04% of all the sessions we see. It seems to be a performance foot gun. Looking at some of the individual domains that are pushing, some really, really get it wrong. Some do get a good benefit though. So it's all over the place. Oh, I did have one stat which I didn't include on the side, which was that for domains that had 1,000 navigations in both test groups, 68 regress and 84 improve when you disable push. So slightly better than the 50-50. And if we weren't working on push all the time, we could work on other fun things. Thanks.
So thank you, Brad. Thank you for both presentations. Mike Lance for comments. John and Kazuo can first crack because I told them to sit down last presentation. But
who should go first?
Kazuho, so I just wanted to comment that, well, push is useful if you have a long fat pipe, but as we move to quick, or as we optimize HTTP2, the buffer becomes shallower and the merit of push becomes small.
Yeah, just to add on that, since you invoked quick, there's also a theory that there's been some experiences with head line blocking with server push that we've made efforts on improving that, and that in the quick world, that problem would also go away, which is an improvement of push over quick. So how that interacts with that, I don't know.
Jenna Iyengar, first you had a slide there that talked about Fastly having an initial window of 100. I'm trying to make it happen. It's not happened yet. So that's actually The paper, I'm familiar with the paper that you're citing there, and I have no idea where they get that number from. I mean, I do, but the number is incorrect. Sorry?
We're time
Probably
constrained.
at the meat of the conversation. So.
Yeah. It was interesting to see the amount of variability that you had in your results. And I was going to ask you if you looked at the population sizes of those different sites. It seems like you might have very low populations, possibly. But it's, yeah. Can you speak to the variability in the data?
Yeah, I mean, so there is variability, and it's not unique to anything with push. It's something that our service performance team has been discovering as we do more analysis on RUM-based data. And so when you measure using synthetic environments, you're much more constrained in terms of your variability. And with RUM data, we see a lot of variability, and there's been efforts at evolving the methodology to control that by using different dimensions, as explained. And so that's what we have now, and there may be further improvements to the methodology to further constrain it. But yeah, there is variability there. And so even in the results that are statistically insignificant in this case, we know that in synthetic tests, we may have seen an improvement, but you don't see it based looking at the RUM data, for example.
So we're actually out of time, but if folks are willing, since this is just an advisory thing, let's go ahead and drain the queues, but no more discussions, please, and please try to keep your comments brief. So, Human?
I'm sorry, I don't know the terminologies. I mean, I can go,
Yeah,
or
go.
do I have to?
Just state your name for the minutes and go.
Human Bashti from Fastly. Just really quick, a couple of things. Since we were talking about numbers, thank you for Chrome for sharing those numbers. I just want to share ours really quick. We don't store any user data. I just did a sample of 90,000 requests on a server. 90,000 streams of H2 there were 150 of them that were pushed. That's 0.15%. Depending on how much you believe in sampling like this, when I did this 3 weeks ago, it was like 80 out of 90,000. I'm not saying it's growing 3 times over 3 weeks, just information. I have a couple of clarified questions for the RUM presentation. Do you have any data volume numbers for how many? I know there was a minimum of 1,000, but how many samples per? I'm guessing each of those 11s were sites. Is that what they were?
Those are sites.
Okay. Yes. Do you have data volume numbers, and maybe more interestingly, what percent of the page views got nuked because they were repeat?
We do have those numbers. I don't have them at this presentation, but we do have those numbers.
Okay. And did those sites, any of them include sites that had their HTML cached? Did everything go to origin to get server think time?
No, not everything. So it depends. Some sites may have it configured to do pushes despite the fact their HTML pages may be cached at the edge.
So if those 11 sites may have had HTML cached pages.
It's possible some subset may have.
So that would totally negate the advantage that push would give for those sites.
Well,
minimize.
Well, theoretically, it should minimize the effectiveness of push in those cases because we couldn't have the idle network time.
Right. Thank you.
Alan from Dell, Facebook. I guess I just wanted to say we have run the slide, the blog post about push is challenging, and there's different implementations in browsers. It makes it hard. It's not uniform amongst browsers how they implement it. It makes push challenging for us, and particularly the way Chrome works in how it does its push cache is incompatible with the way we want to operate things, and we're not able to really push effectively to Chrome. So, I think that may be one reason why from the Chrome side you have one perspective, and then from the CDN side you may see something else. They're seeing other browsers that have different implementations of push.
Eric Nygren, question for Brad. I think one thing that might be interesting to do is also look at if there's a way to filter that by cases where the push is happening in the server think time. So for example, cases where all the pushes that are coming in before you actually start receiving the response for the base object that was requested. Because some of this might be that one of the side effects here is if you have other stuff you can send, you should never push, and maybe that's useful guidance. And it might be interesting to see if we can kind of decouple these cases of push is useful if you have nothing else to send yet because you're still doing something on the server side, from the people really badly misusing it by pushing stuff when they really should be sending something else instead.
That's a good point.
Mike Bishop, I will also observe that both of you are collecting data off of Chrome and off of particular sites. So that's a good place to try and figure out where your methodology is diverging, because you have divergent results. And I'm wondering if well, one thing I observe is you did all navigations and you have only first navigations. So that's going to impact things a lot. I think, and Chrome's numbers would probably improve if we had cache digests because of that. And I'm also wondering if it might be useful to pick a set of sites and do a joint experiment from both sides and see if numbers are still divergent, and if so, why.
We had a hallway conversation along those lines before this.
Okay. Well, thank you both. That was really interesting. I think we want to encourage more data like that as we go on. That's really good. Thank you. Right before we go, two things real quick. One, we're having a session, a barb-off, just next door in about 5 minutes for SRV and HTTP, if you're interested in that. And two, where are the blue sheets? Does anyone know where the blue sheets are? There's one. And is there another one floating around there somewhere? Okay, well, hopefully we'll find it. Oh, thank you. Great. All right. Thank you all very much. And we have another session tomorrow.
See you then. Thank you. Thank you. Yes, I was too. Yeah, it's not here in PDF. I think it's fine. And we have. And we have like. Yeah, it's in. Oh, this is Mark's boss. Yes, I'm hoping not to have to say it. Thanks.
I'm trying to get this sent to like email. I just sent it out. Yes. Chicken puts with fireworks. I don't know.